Good evening, children.
Good evening.
Good evening.
Good evening.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening. We have to continue from here. Last class, there was a question on statistics, right? That test which we took up on similar triangles. There was one question on statistics. Anyone has completed that? There was I think a less than cumulative frequency distribution. So you had to prepare the frequency distribution and find the median. Am I audible?
Yes, ma'am.
Yeah, okay. The low voices suggest that you haven't finished. Children, you should have tried it. See, you should have finished it and reminded me for the answer. Huh? See, I remember. Okay, please complete it, and at least one of you should remind me for the, for the answer in the next class.
Yes, ma'am.
Yeah, that's nice. All right, children. So here, see, we are going to prove that the ratio of the corresponding sides is the same as the ratio of the corresponding medians in two similar triangles. Listen carefully. When two triangles are similar, we know that their corresponding sides will be proportional. In two similar triangles, corresponding angles are equal and corresponding sides are proportional. Like here you can see triangle ABM similar to triangle DEN. If this is given to us, supposing, see, this is to prove that. Okay, I'm just telling you, if it is given, if it's given that triangle ABM is similar to triangle, okay, or let's take up this given here. See here, triangle ABC is similar to triangle DEF is given to us. So when these two triangles are similar, it means their corresponding angles are equal. Angle A is equal to angle D. Angle B is equal to angle E. Angle C is equal to angle F. In two similar triangles, corresponding angles are equal. Also, in two similar triangles, corresponding sides are proportional. So what are the ratios we have on the corresponding sides? AB by DE is a ratio of the corresponding sides. Side AB corresponds to the side DE, or you can say side BA. See, side AB, side BA refers to the same side. ABBA refers to the same side. Okay, so side AB corresponds to the side DE. So the ratio on the corresponding sides will be AB by DE. The ratio on the corresponding sides AB and DE is AB by DE. Then side BC corresponds to the side EF. So the ratio will be BC by EF or CB. See, BC, CB represents the same side. BC, side BC, side CB, same side, same line segment. So BC by EF is a ratio on the corresponding sides. Then finally AC by DF. These three ratios are equal. If these two triangles are similar, then these ratios will be equal, which means the corresponding sides are proportional. Equality of two or more ratios is said to be a proportion. Equality of ratios is called a proportion. So the ratio AB by DE will be equal to the ratio BC by EF will be equal to the ratio AC by DF. In two similar triangles, corresponding angles are equal and the corresponding sides are proportional. We know that. This much we know. What are we going to prove now? We are going to prove that the ratio of the corresponding similar triangles, children. Okay, see, it's given here. In two similar triangles, we're going to prove that the ratio of the corresponding sides is the same as the ratio of the corresponding medians. We need to understand what we're going to do. That's why I'm just pausing. In two similar triangles, we're going to show that the ratio of the corresponding sides is the same as the ratio of the corresponding medians. Okay, so we'll be given two similar triangles. So here triangle ABC is similar to triangle C. You will be given a statement like this, that prove that in two similar triangles, the ratio of the corresponding sides is the same as the ratio of the corresponding medians. You will be asked to prove the statement. So then you have to take up two triangles like this. You can call them A, B, C, D, E, F, P, Q, R, X, Y, Z, whatever. Okay, so this is how the proof will go. So we're given two similar triangles, not two triangles, two similar triangles. So this is the triangle DEF given to us. Now see here, A, B, C, D, E, F. Now the vertex A, we should understand what is meant by the ratio of the corresponding medians. What do we understand by corresponding medians? So here vertex A corresponds to vertex D, because here A, B, C, A, vertex A corresponds to vertex D. Vertex A corresponds to vertex D, which means the median from A corresponds to the median from D. Vertex A corresponds to vertex D, which means the median from vertex A will correspond to the median from vertex D. That is what we understand by this term corresponding medians. So not any two medians, corresponding medians. Medians from the corresponding vertices falling on the corresponding sides. All right. So vertex A corresponds to vertex D. So let's take up the median AM from the vertex A on the side BC and the vertex DN from the vertex D on the side EF. So AM, see, corresponding medians, vertex A corresponds to vertex D. So the median from A will correspond to the median from D. AM median in triangle ABC, DN median in triangle DEF, which means M is the midpoint of BC, N is the midpoint of EF. So given two similar triangles, AM and DN are the medians on the corresponding sides from the corresponding vertices. AM and DN are the medians on the corresponding sides from the corresponding vertices. That's understood. Or you can just write AM and DN are the corresponding medians. All right. Now, what do we have to prove? We need to prove, this is what we have to prove, okay? We have to prove that triangle ABM is similar to triangle. All this will be given, children. Now, don't see, this is what you'll have to remember. You need to remember this, that the ratio of the corresponding sides is, excuse me, that in two similar triangles, the ratio of the corresponding sides is the same as the ratio of the corresponding medians is what you'll have to remember. That's one thing. Okay. Now, regarding this proof, I've just written that to highlight, that's all. Regarding this proof, all this info will be given to you. All right, to prove this first one, second one, third one, all this will be given to you. Not that from the statement you have to write all these three. No, no, not like that. All right. Okay, so we need to prove that triangle ABM, this one, is similar to triangle DEN. This is one thing. Then we need to prove that BC by EF, see here, BC by EF, corresponding sides. BC by EF is equal to AM by DN. See here, ratio of the corresponding sides is the same as the ratio of the corresponding medians. Can you understand that here from this proportion? What is BC by EF? BC is a side, EF side. corresponding sides there. So BC by EF, corresponding sides. AM by D, corresponding medians. Ratio on the corresponding sides, ratio on the corresponding medians. We'll have to show that they're equal. These two ratios are equal. So here we are proving that the ratio of the corresponding sides is the same as the ratio of the corresponding medians. And also we'll have to show that triangle AMC is similar to triangle DNF. See, such questions will be asked with this given information. I have put everything in the same question. That's all it is. Proof. Such results will be asked. You'll be asked to prove such results. I've just put everything in one proof. That's it. So what is given to us? Two similar triangles. What are given to us? Two similar triangles. And then we have the medians falling from the corresponding vertices, or medians falling on the corresponding sides. And given this, we need to prove these results. Clear, children? Clear about what we are going to do? Am I audible?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. So this is what we'll have to prove. Very simple proof. All right. So whenever we are given that two triangles are similar, you please write out this first. Because triangle ABC is similar to excuse me. Because triangle ABC is similar to triangle DEF, it means angle A is equal to angle E, angle C is equal to angle F, and also these the ratio of the corresponding sides are also equal. That is, corresponding sides are proportional. Please write these two results because we are given ABC similar to DEF. So these results follow in two similar triangles. Please write that first. Now take up the triangles which we have to prove are similar. All right. So we have to show the triangle ABM. We'll have to show the triangle ABM. This one is similar to this one. We need to show that this. Now, children, tell me, is AB by DE equal to BC by EF? BC by EF. See this one, AB by DE equal to BC by EF. See, since we have to prove that this triangle is similar to this triangle, we need to take up relevant sides. We need to take up the ratios on the relevant sides. So you understand that AC by DF is irrelevant to these two triangles. AC, the ratio AC by DF. The ratio AC by DF is irrelevant to these two triangles. See, we have these three ratios here. We have these three ratios. AC by DF is irrelevant. So let's think about these two. AB by DE. AB by DE. Yeah. Okay, relatable. Then BC by EF. BC, not quite, but then BC. It's, like a part of it is BM. And EF, okay, part of it is EN, which are the sides of triangle ABM and DEN. Agree, children? Shall we go ahead with these two ratios?
Yes, ma'am. Yes, ma'am.
Okay, we'll go ahead with these two ratios. Or we're just ignoring this because sides AC and excuse me, sides AC and DF do not relate to these two triangles. So we'll go ahead with these two ratios. Since you understand this, I'm not repeating. Fine. Let me go ahead. So now we'll take up these two ratios. AB by DE is equal to BC by EF. Now, which of these two ratios is completely relatable to these two triangles ABM and DEN?
Ma'am,
AB by D.
AB by DE is equal to
AB by DE. No, AB by DE is completely relatable because AB by DE.
Yes, ma'am.
Okay. But BC by EF should be modified, right?
Yes, ma'am. We can take as BC by 2 by EF by 2, and we will get as BM by EM.
Yeah. BC by EF should be modified. Should be modified meaning you must do some changes so that you introduce the sides of triangle ABM and BEM. So with BC you can get BM and with EF you can get EN. Yes or no? You can change, you can try to change BC to BN and EF to EN. Yes or no, children?
Yes, ma'am. We can take BC by 2 by EF by 2.
So we can proceed in two different ways. Either you can multiply both the numerator and denominator by half. Okay, so like when B, okay, it's like this. When two things are equal, their halves are also equal, right? Now, when you have the fraction 5 by 10, am I audible, children? Is my voice clear?
Yes, ma'am.
No, ma'am. Sometimes it's breaking for me.
In between, your voice is breaking.
Ma'am.
Okay, let me continue. Just let me know when it's not clear. Okay. Okay.
Yes, ma'am. Okay, ma'am.
Okay. So now, so when you have the ratio, say 20 by 30, 20 by 30, how do you reduce it to 2 by 3? You divide both the numerator and denominator by 10, right?
Yes, ma'am.
When we have 20 by 30, no, listen to me. When we have the ratio 20 by 30, we reduce that to 2 by 3. What's actually happening there? We divide the numerator 20 by 10 and the denominator 30 also by 10. So you're actually dividing both the numerator and denominator by 10, which gives us 2 by 3. Yes or no?
Yes, ma'am.
Okay, so here also BC, you can divide the numerator and denominator by 2. So we can take this further as BC by 2 by EF by 2. That is AB by DE is equal to BC by 2 divided by EF by 2, dividing both the numerator and denominator by 2. 20 by 30 is nothing but 2 by 3. Children, let me just change my network. Am I audible, children?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Ma'am.
We'll write BC, we'll alter BC by EF. So we can write BC by EF as BC by 2 by EF by 2. That is, we can divide the numerator and denominator by 2. BC by 2, EF by 2. Now what is BC by 2? What is BC by 2? BM. Because half of BC is BM. Because M is the midpoint of BC. Because AM is the median. AM is the median, which means M is the midpoint of BC. DN is the median, which means N is the midpoint of EF. So BC by 2. See, I'm saying we can go ahead with this ratio, but we need to prove that this triangle, listen, we need to prove that this triangle is similar to this triangle. We'll go ahead with this proportion. AB by DE is fine. We'll change BC by EF. We'll divide the numerator and denominator by 2. So BC by 2, half of BC can be written as BM. Yes or no? Please acknowledge.
Yes, ma'am.
Yes, ma'am.
And what is EF by 2? What is
EN.
EF by EN? So what is the new ratio you get? BM by EN. BM by EN. Is it completely relatable to triangle ABM and DEN?
Yes, ma'am.
Yeah, because BM is the side of this triangle ABM and EN is the side of the triangle DEN. So now we have this ratio AB by DE is equal to BM by EN. Which is the angle included by the sides AB and BM?
E, ma'am.
Angle B. And the angle included by DE and EN? Angle E. So are the included angles equal? Angle B and angle E?
Yes, ma'am.
Angle B is already equal to angle E. So by SAS similarity criterion, these two triangles are similar to each other because AB by DE is equal to BM by EN. Sides proportional. Included angle equal. Angle B is equal to angle E. Included angle, not any angle. The sides AB and BM include angle B. The sides DE and EN include angle E. We know that AB by DE, we proved that AB by DE is equal to BM by EN. And the included angles, angle B is equal to angle E. Therefore, by SAS similarity criterion, ABM is similar to triangle DEN. You can also handle this ratio in a different way. What's the other way of writing BC? BC can be written as 2 times BM.
2BM.
Or 2 times MC. But MC is not relevant. So we'll not write 2 times MC. We'll write 2 times BM. When you this ratio BC by EF can be handled in another way. You can write instead of BC, you can write an equivalent. Twice BM. Instead of EF, you can write what? Instead of EF,
2EN.
And 2EN, ma'am.
twice EN. So now 2 and 2 will get cancelled. 2 in the numerator and 2 in the denominator will get cancelled. And that will give you BM by EN. So you can get BM by EN this way also. So you can divide both the numerator and denominator by 2. Or you can write BC as 2 times BM. And EF as 2 times EN. SAS rule the triangles are similar. And then in 2 similar triangles, their corresponding sides are proportional. We know that in 2 similar triangles, corresponding sides are proportional. Children, now you can start writing. Now, as you write, you will understand better. Yes, start writing. Please take down the figure. Write down what is given, what is to be proved. Just make a note of this. Just say note in 2 similar triangles. Just include that in two similar triangles. The ratio of the corresponding sides is the same as the ratio of the corresponding medians. Just write that as a note. And please work this.
Completed, ma'am.
Okay.
Ma'am, can you repeat the notes, ma'am?
Now, what you see right on top, see here, Srinivasan, right on top. Please write this. Just include in two similar triangles. Okay. In two similar triangles, the ratio of corresponding sides is the same as the ratio of the corresponding medians. On top we have here. Just include in two similar triangles. My voice should be clear now. There's no break, right? My voice is clear?
Yes, ma'am.
Yeah.
Ma'am.
Okay, yeah. Very simple, very important proof, children. That's why I want you to write now during the session. All of you, please write during the session. Don't take a screenshot and waste your time now.
Ma'am.
Yeah.
Ma'am, for the AMC is similar to DNF, I used the SSS, ma'am.
Yeah, you can use SSS because you know AM by DM. Yes. You can use SSS. Completed?
Ma'am.
1 minute, ma'am.
Okay. Done, children?
Yes, ma'am.
Yes, ma'am.
All right. So the second part here, we have to prove that BC by EF is equal to AM by DN. So from the similarity of these two triangles, ABM similar to DEN, we get AB by DE. See, we'll have to prove that BC by EF. We have to prove BC by EF is equal to this. But we know that BC by EF is AB by DE. We have to prove that BC by EF is equal to AM by DN. But we know that BC by EF, AC by DF, AB by E, all these three are the same. We know all these three are the same. All these three ratios are the same. We need to prove BC by EF is equal to this. It's the same as proving AC by DF is equal to this, because all these three are equal. So when you have to prove that this one is equal to AM by DN, it's okay if you prove this also is equal to AM by DN, or this one is equal to AM by DN. Because these ratios are equal, if this is equal to AM by DN, that in turn means this is also equal to AM by DN, and this also is equal to AM by DN. So from the similarity of these two triangles, we just proved that these two are similar. So we can't get BC by EF from these two triangles, because BC and EF are not the sides of these two triangles. So we can't get BC and EF, but we can definitely get AB and DE. AB and DE, see here, AB and DE. So we know that AB by DE, you need to prove is equal to AM by DN. See here AM by DN. So we get this ratio AM by DN. But we are not finding BC by EF. Instead of BC by EF, we find AB by DE. Yeah, see here AB.
Ma'am, your mic is muted.
Children, am I audible?
Only you are audible.
Now, yes. Now,
Yes, ma'am.
Okay. So I was telling you that we need AM by DN, which we have here, AM by DN is equal to BC by EF. We don't have BC by EF, but instead we have AB by DE here, AB by DE. Okay, let's write that. AB by DE is equal to AM by DN from the similarity of these two triangles. But AB by DE is equal to BC by EF. These two are equal. So from these two results, it follows that BC by EF, because this is common to both here. This one is equal to this. The same thing is equal to this also. That means BC by EF is equal to AM by DN. It's like A is equal to B, but A is also equal to C. So B is equal to C. This is common, right? So call this A. A is equal to B. The same A is equal to C. A equals B, A equals C, which means B is equal to C. These two are equal. B is equal to C. So we proved the second result. The third one, is AMC similar to DNF. So you can repeat just for the sake of practice. I repeated the same procedure. I didn't want to use a different one. Now I'll be sharing the other ways by which you can prove that these two triangles are similar. Because if I write a different way here, you might, it may be misleading. So I use the same procedure, a similar procedure. I'll tell you the other ways of proving that they're similar. So the third part is to prove that AMC is similar to DNF. That is, this triangle AMC is similar to DNF. So proceed in the same way, children. This I'm not explaining. You should understand this. I'll just give you time for that. Similar to the way we did the first one, the way we handled the first one. From these three ratios, take the relevant ratios. From these three ratios, take the relevant ratios. So for these two triangles, for these two, my screen is visible, right, children?
Yes, ma'am.
Yes, ma'am.
Yeah.
Yes, ma'am.
Yes, ma'am.
Okay, children. So for these two triangles, the ratio AB by DE is irrelevant. So ignore this ratio AB by DE. Go ahead with these two. Go ahead with these two. AC by DF, BC by EF. Go ahead with these two. Because AC by DF is completely relevant. AC by DF is completely relevant. And BC by EF is relevant. Not completely, but we can make it completely relevant. BC by F. So let's change that. So you know BC can be written as twice CM and EF can be written as twice NF. 2 times NF is EF. 2 times MC is BC. Instead of BC, we write its equivalent. Twice CM is BC. Twice FN is EF. 2 gets cancelled and we have this. So now completely relevant. CM by FN. CM by FN. Completely relevant. So sides of the triangles which we have to prove are similar. The sides are proportional. And the included angles. C is equal to angle F. Angle C is equal to angle F. Yeah, that we already know C is equal to F. By SAS rule, SAS similarity criterion, the two triangles are similar. And I already told you how to name the triangles. See, now mostly children, what we do is in this, meaning in the question you will be given, no, you will be asked to prove. So normally we just write the same order, whatever is given. Therefore, triangle AMC is similar to DNF. But I'm saying, so maybe here you will just copy whatever is given here, you will just write it out. But otherwise, you know how to name it. I've told you how to name it. So here you can see AC, CM, ACM, DF, FN, DFN. AC, C. The numerators are the sides of one triangle. See here, AC, CM. The numerator, AC, CM. AC numerators will be the sides of one triangle. The denominators DF, FN, DF, FN, DF, FN, sides of the other triangle. So you can call the first triangle ACM and the second triangle DFN. That is also a correct order. ACM, see here, ACM, DFN, DFN. Okay. Now we already proved. Now we'll see alternate methods for doing this one. For doing this, how else can we do this? Okay. So now we have already proved in this one we've already proved that this triangle is similar to this triangle, which means this angle is equal to this angle. This angle is equal to this angle. We're just seeing, we can prove that these two triangles are similar by AA similarity criterion also. This one is similar to this by the AA similarity criterion. We're going to see that now. All right. So since this triangle ABM is similar to DEN, these two angles are equal. Corresponding angles. M corresponds to N. See here, ABM, DEN. M corresponds to N. So now these two angles are equal. Supposing say 70 degrees, 70 degrees. 70, 70. What will be the measure of this angle? What will be the measure of this angle?
Can you repeat, ma'am?
No. I'm saying like these two angles are equal. Say they are 70 degrees.
Yes,
What will be the measure of this angle?
110.
110.
What will be the measure of this angle?
110.
110. That means because they form a linear pair, when this angle is equal to this angle will be equal to this angle. And already angles C is equal to angle F. It's given to us. Angle C is already equal to F. So by doubly similarity criterion, AMC is similar to DNF. Angle M, that is angle, let me number it, angle 1 is equal to angle 2. Angle 1 is equal to angle 2. And angle C is equal to angle F. So by doubly similarity criterion, the two triangles are similar to each other. You can also do it like this. So your steps will go like this. Please write down. Please write down the alternate proof for 3. I've numbered the angles 1, 2, 3, 4. Write down angle 1 is equal to angle 2. Angle 1 is equal to angle 2. In bracket, the reason is triangle ABM similar to triangle DEN. This one, ABM similar to DEN. We proved that these two triangles are similar. So angle 1 is equal to angle 2. Angle 1 is equal to angle 2 because triangle ABM is similar to triangle DEN. Next step, 180 minus angle 1. If 1 is equal to 2, 180 minus angle 1 will be equal to 180 minus angle 2. So write down next step, 180. If angle 1 is equal to angle 2, 180 minus angle 1 is equal to 180 minus angle 2. That's the next step. 180 minus angle 1 is equal to 180 minus angle 2. Below that, 180, what is 180 minus angle 1?
Angle 3.
Angle 3. So instead of below, next step, angle 3 is equal to, what is 180 minus angle 2?
Angle 4.
Angle 4. So you get a new result. Angle 3 is equal to angle 4. I'll repeat the 3 steps. Angle 1 is equal to angle 2. Next step, 180 minus angle 1 is equal to 180 minus angle 2. Next step, angle 3 is equal to angle 4. Then you can also write this. Angle C is equal. No, not you can also write. You must write angle C is equal to angle F. So this is one information. Angle 3 is equal to angle 4 is one thing. And then angle C is equal to angle F. That because we already know C is equal to F. The triangle is similar. C is equal to F. So do we agree, children? By AA similarity criterion, AMC is similar to DNF. Yes or no?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
All of you, please check if you are clear.
Yes, ma'am. Yeah.
Yes, ma'am.
Okay. But don't think this angle will be equal to this angle, children. It's a median. AM is only the median. So this angle is not bisected. Angle A is not bisected. Angle D is not bisected. These two portions are not equal. Angles A and D, they're not bisected. Okay, so don't think this angle is equal to this angle and this is equal to this. No. When AM is the median, M is the midpoint of BC. That's all. DN is the median. N is the midpoint of EF. That's it.
Ma'am, but angle BAM will be equal to angle EDN, no, ma'am?
DEN. ABM, DEN. Yeah, that follows because the triangles are
No,
similar.
ma'am. BAM. Angle BAM.
BAM will be equal to?
Angle EDN.
That after we prove that the triangle is similar. Not before that. Arnav, at which point are you asking me this question? After we prove the first one?
No, ma'am, just a random question. You were saying bisected. That's why I just thought of it.
No. Yes, see, this angle will be equal to this angle when after you prove that these two triangles are similar, not
Yes,
when we start the proof. When we are trying to prove this, they are not equal.
Got it, ma'am.
Yeah. So, questions will be like, you'll be given BC, the length of BC, the length of EF. See, like BC's, I'm just saying randomly, BC 10 centimeters, EF 7.5 centimeters. Then you'll be given AM and asked to find DN. So you must write this proportion. You must write this proportion that because the triangles are similar, BC in two similar triangles, the ratio of the corresponding sides is the same as the ratio of the corresponding medians. So then you should write out the value of BC given, EF given, and maybe if AM is also given to you, you can find DN by cross multiplying. Now tell me if this is true or false. AC by true or false?
False, ma'am.
Children, that is now we know that
True,
in two
ma'am.
similar triangles. No, this is we now know that in two similar triangles, the ratio of the corresponding sides is the same as the ratio of the corresponding medians. Now we know that result. So I'm just telling, have I expressed the result correctly? Have I expressed the result correctly? Can you see the ratio of, can you see one ratio should be the ratio of the corresponding sides. The other ratio should be the ratio of the corresponding medians and an equal to sign in the middle.
False.
One should be a ratio of the corresponding sides. The other
False, ma'am. We cannot tell, ma'am.
The other one should be the ratio on the corresponding medians and equal to. We know it is true. This is true. In two similar triangles, the ratio of the corresponding sides is equal to, is the same as the ratio of the corresponding medians. Is true. But have I presented that information correctly?
No, ma'am. It's wrong, ma'am.
No, ma'am.
They are showing in the same triangles ratio.
So
It
correct
should
this
be
one.
AC by DF is equal to AM by DN.
It should be AC by
DF is equal to AM by DN.
AC by DF is equal to AM. This is correct, is it?
Yes,
This
ma'am.
one's correct, huh? Okay, tell me the result when you cross multiply this. What will you get when you cross multiply this?
AC into DN is equal to DF into AM.
When you please cross multiply this and check. Please cross multiply this and check. Are you getting the same results?
Yes, ma'am.
Yes, ma'am.
Yeah, so you can write it that way also. You can write, see here, this is of one triangle. This is of one triangle. You can also write it like this. This is the side of one triangle and the median of the same triangle. This is the side of one triangle and the median of the same triangle. So you must write here the corresponding side of the other triangle and the corresponding median of the other triangle. Nothing. Don't worry. I was just trying to say that you can also write it like this because it's the same as this one. AC by DF, ratio of the corresponding sides. AM by DN, corresponding medians equal. You can exchange this. You've seen it in the material earlier. I've used the term alternando. Alternando. AC, actually, we know that AC by DF, the ratio of the corresponding sides AC by DF is equal to what is that? AM by DN. You can also extend this. If you bring this down here and take this up here, AC by AM is equal to DF by DN is also fine. As long as you can cross multiply and get the same result. I hope I've not confused you. I said you can exchange A by B is equal to C by D. Can also be written as, you can write the C here, A by C, and put the B here. That's all. Sometimes you'll be asked like this, just informing you. This property is called alternando. Because when you cross multiply, you get the same thing. A into D is equal to B into C or C into B. So you will be, so there are 4 line segments here. There are 4 line segments in this proportion. In this proportion, there are 4 line segments. 2 sides and 2 medians. You will be given 3 values. Any 3 values and asked any 3 values which can be filled here. And you will be asked to find the 4th one. Fine, children? So when you have to prove that the ratio, am I audible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. So when you have to prove that the in 2 similar triangles, the ratio of the corresponding sides is the same as the corresponding medians, you'll have to do this. You should multiply. You should either write BC as twice BM and EF as twice EN, or I said you can also divide by 2. You can divide the numerator and denominator by 2. So this is the approach, and it's proved using the SAS criterion. SAS. It's proved using the SAS criterion. Once when you prove, when you prove that this triangle is similar to this by SAS, this has to be proved by SAS. You can prove this by SAS or AA or SSS. SSSC, I did not tell you today, children, because I'm scared it shouldn't be confusing for some of us. So now I made the easier one first. AA is easier. We'll see SSS. When we go ahead, we'll see SSS also. Or maybe next class we'll come back to this. I'll let you know. You can prove that these 2 triangles are similar by SSS similarity criterion also. So you can see the, please write this as a note. Please include in 2 similar triangles, okay? In 2 similar triangles, the ratio of the corresponding sides is the same as the ratio of the corresponding altitudes. In 2 similar, this is the next note. In 2 similar triangles, the ratio of the corresponding sides is the same as the ratio of the corresponding altitudes. Please write down that.
Completed, ma'am.
Yeah. So this is what we are given. two triangles ABC, DEF, which are similar to each other. ABC is similar to DEF. CM and see, that's why I've taken altitudes, medians from different vertices, so that we understand the meaning of the phrase corresponding altitudes, corresponding medians. So the altitude CM corresponds to the altitude FN, because C and F are the corresponding vertices. See here, C corresponds to F. So the altitude from C, CM, corresponds to the altitude from F, FN. Or you can even say the AB and DE are the corresponding sides. AB and D are the corresponding sides. So the altitudes on the corresponding sides are also the corresponding altitudes. You can say corresponding. You can find out if they are corresponding altitudes, with with respect to the corresponding sides or the corresponding vertices, corresponding angles. So you cannot take CM here and say like DN here. You cannot draw an altitude from D here, because that proportion will not be true. The altitude from CM corresponds to the altitude from C corresponds to the altitude from F, because C and F are the corresponding vertices. Am I making that point clear, children?
Yes, ma'am.
Yes, ma'am.
All of you, please tell me.
Yes, ma'am.
Yes, ma'am.
All right. Yeah. So what are we given here? Triangle ABC is similar to triangle DEF. CM and FN are altitudes. You can say altitudes from the corresponding vertices, or you can say altitudes on the corresponding sides. I told you, children, both amounts to the same thing. CM and FN are altitudes on the corresponding sides, or you can say from the corresponding vertices. Okay. Now we need to prove these three results. See, quite similar to the earlier one. Earlier we were dealing with medians, here with altitudes. Here with altitudes. Excuse me. So now when the whole triangles are similar, the whole triangles ABC and DEF, the whole triangles are similar. Whenever we have two similar triangles, let's first write down the results that follow from the similarity of the two triangles. In two similar triangles, corresponding angles are equal and their corresponding sides are proportional. Let's first write out that. That's what you see here. And what's an altitude? It's right angle. It makes a right angle with the base. CM is an altitude. That means it makes an angle of 90 degrees with the base AB. Similarly, FN makes an angle of 90 degrees with the base DE. Altitude, no? So now how do we show that? So now how do we show that these two triangles are similar? We need to prove that this triangle is similar to this triangle, is similar to this triangle. Easy, no? Because angle A.
Ma'am, we can take AA criteria, ma'am.
Yeah, because angle A is equal to angle D. Just take up the two triangles. You'll have to give information from the two triangles. So in these two triangles, we'll have to show that this triangle is similar to this triangle. So angle A is equal to angle D. Here, see here, angle A is equal to angle D. Angle A is equal to angle D. Then angle 1 is equal to angle 2, 90 degrees. Double A similarity, the triangles are similar. Yes, this you should understand right now. I'm not making my work easy. This is simple for you to understand. So to prove this result, we use the double A similarity criterion. Double A. For medians, it is SAS. Medians, it is SAS. Altitudes, double A. See, when you have to prove that these two triangles are similar, I've told you that this information should be of this triangle and this information should be of this triangle. So it's like angle 1 of this triangle is equal to angle 2 of this triangle. Angle A of the first triangle is equal to angle D of the second triangle. Please write.
Completed.
Yeah. What about the others?
Ma'am, 1 minute.
So you will be given two similar triangles. You have to take up the corresponding altitudes. So you can draw the altitudes from, from A and D corresponding vertices, or from B and E, or from C and F. You can take this altitude. You draw this, you must draw it from here. Or if you draw from B, if you draw the altitude from, no, they'll be concurrent, I'm sorry. Or if you draw it from B, if you draw it from B, then you must draw it from E, corresponding altitudes. And basically what we are proving here is the triangles on either sides of the altitudes are similar to each other. That's what we're proving. We're proving that the triangles on either sides of the altitudes are similar to each other. Here, AMC, DNF. AMC, DNF, this one. CMB, FNE, this one, and this one. So we are proving that the triangles on either sides of the altitudes are similar to each other. Earlier we proved that the triangles on either sides of the medians are similar to each other. That one, and then also that the ratio of the corresponding sides a ratio of the corresponding sides is the same as the ratio of the corresponding altitudes. That's what is this? AB by DE. See here, AB. In two similar triangles, these are the corresponding sides, AB by DE. In triangle ABC and DEF, AB and DE, corresponding sides, AB by DE is equal to CM by FN. So here we are just proving that the triangles on either sides of the altitudes are similar to each other. Also, that the ratio of the corresponding sides is the same as the ratio of the corresponding altitudes. And this is all done using AA. Class, use the emoji. Raise your hand. Arnav, Vadi, Ravya, Muttuvel, Manasa, Harshita, Sudarshan, Parkavi, Srinivasan, Priya, Shakti, Shabari after a long time. Nivedita, Priyadarshini, Shriya, Tirunesh, Nafi, Lakshita, Rakshan, Shruti, Ashwin, Anish, Balaharish, Reshmi and Akshara. Very good. Thank you, children. Now, one of you unmute yourself and tell me how will we prove that how will we prove that this triangle is similar, that is this triangle, this one is similar to this one. How do we prove that this triangle is similar?
Can I tell you?
Yes.
As triangle ABC is similar to triangle DEF, angle B is equal to angle E, ma'am.
Yeah.
And they are given that CM and FN are altitudes, ma'am.
Yeah.
So angles CMB is equal to angle FNE is equal to 90 degree, ma'am. That's
Very
the AA criteria. We can prove that both are similar.
Very good. Very good, Shakti. Yes. Perfect. Somebody else tell me how is triangle AMC similar to DNF?
Ma'am, same only. Angle, since triangle ABC is similar to triangle DEF, so angle A is similar to angle A is equal to angle D.
Good.
And CM and FN are altitude, so angle 1 and angle 2 is equal to 90 degrees.
Very good.
So by AA similarity criterion, we get triangle AMC is similar to triangle DNF.
Very good. Both of you. Good. That's it.
Or we can use SAS criteria.
SAS.
Yes.
Yeah, please tell me how will you use SAS?
For
which one? One. For the first one, no? For this one?
Yes, ma'am.
Okay, tell me.
As triangle ABC is similar to triangle DEF, you will get as AB by DE is equal to AC by DF.
AB by D is equal to BC by F. Okay.
Ma'am, AC by DF, ma'am.
AC by DF. Okay. Yeah, I get you. Okay.
So AB by 2 and DE by 2 is equal to AC by DF, ma'am. So you'll get as AM by DN is equal to AC by DF, ma'am.
But I have one question. How do we know that is M the midpoint of AB?
No, ma'am.
Then how can we write AB by 2 as AM?
Ma'am, we cannot tell.
We can't. Yeah, so we can't do that way. AB by 2 is not AM because M is not the midpoint of AB.
Yes.
Yeah. So we cannot do it like that. If CM was the median, you're right. So M is not the midpoint of AB, N is not the midpoint of DE. I can't say not, need not, because in an isosceles triangle, yes, when the two triangles are isosceles, we have to take a general one. So altitudes altitudes are perpendicular to the base. They don't meet the base at the midpoint. They need not meet the base at the midpoint. In isosceles and equilateral triangles, yes, we have properties like that. So here it is using AA similarity criterion, children. So here also you will be given four of the four values, 4 line segments. You may be given the values of 2 corresponding sides in the triangles and 1 altitude, and you will be asked to find the length of the other corresponding altitude. So you have to write this proportion. You'll have to write this proportion. Substitute the values and find whatever is missing. And this one, children, the second part, see, it's very simple. We have to prove that AB by DE. Okay, AB by DE is equal to the ratio of the corresponding altitudes. Instead of AB by DE, you can prove BC by EF is equal to this, or AC by DF is equal to this, because all these three ratios are the same. See here, we know that these three ratios are the same. AB by DE, BC by EF, AC by DF, all these three ratios are the same. We have to prove that AB by DE, this one, AB by DE, this one, is equal to CM by FN. AB by DE is equal to CM by FN. This is what we'll have to prove. So if you can't get this directly, you can prove BC by EF is equal to CM by FN, or you can also prove that AC by DF is equal to CM by FN. But since all these three ratios are the same, it means that all these three are equal to CM by FN. Ratio of corresponding sides, ratio of corresponding sides, ratio of corresponding sides. All these three are equal to CM by DN, CM by FN. All these three are equal to CM by FN, the ratio of the corresponding altitudes. Each of the ratios is equal to CM by FN, children. So how do you present the answer? See, we know because we proved that these two triangles are similar, or we know that AC by DF. So you'll wonder why, how do we know that we have to write only these two? That's what. Because we know we have to prove AB by DE. But we don't have AB and DE here. But we have AC and DF. So write AC by DF is equal to MC by NF. Because MC is nothing but CM. Okay, or you write all the three ratios and you can ignore the one which you don't want. 1 minute. If you feel, of the three, which two to write. So now that AMC, see here, AMC is similar to DNF. So we know that AM by DN is equal to MC by NF. Sorry, NF this is equal to AC by DF. So CM by NF we need. Where is that? CM by NF, this one we need. Ratio of corresponding altitudes. Then we have to actually get CM by Fn is equal to AB by DE. We don't have AB by DE here. So which one will you choose? Will you choose this or this? So since we have to prove we have to prove AB by DE is equal to CM by Fn. CM by Fn we have. Now we don't have AB by DE here. So what will we choose instead of AB by, we don't have AB by DE. So, but we know that AB by DE is equal to AC by DF. So we'll choose this. With this. That's why we write those two. AC by DF. AC by DF is equal to MC by NF. But AC by DF is equal to AB by DE. AC by DF is equal to AB by DE. So this is common to both. See, AC by DF is common to both. So AB by DE is equal to MC by NF. So we spoke about corresponding medians, we spoke about corresponding altitudes, and this is corresponding angle bisector segments. Angle bisector segments. These are the line segments that can be drawn from the vertices to the opposite sides. You can draw medians, you can draw altitudes, you can draw angle bisector segments from the vertices to the opposite side. So here angle bisector segments. You'll have to write write down note in two similar triangles. You know what to write down. Have you written note in two similar triangles, the ratio of the corresponding sides is the same as the ratio of the corresponding angle bisector segments. Angle bisector segments. Segments, line segments, angle bisector segments. Okay, so now BE is the bisector of angle B. QF is the bisector of angle Q. So that means angle 1 is equal to angle 2 and 3 is equal to 4 because BE bisects angle B. It divides angle B into two equal halves. QF bisects angle Q, which means angle 3 is equal to angle 4. Now tell me, is E the midpoint of AC?
No, ma'am.
No. Is F the midpoint of PR?
No, ma'am. They gave only as angle bisector.
No. And is BE perpendicular to AC? Is BE perpendicular to AC?
No, ma'am.
No. And QF perpendicular to PR?
No, ma'am.
No. So E is not the midpoint, F is not the midpoint. And also B is not perpendicular to AC. QF is not perpendicular to PR. We only know that angle 1 is equal to angle 2. That is BE bisects angle B and QF bisects angle Q. Angle 3 is equal to 4. You see? I told you. These three questions, I've just made the questions, whatever we have to prove, I've just made them look alike. So everywhere we prove, in all these three, we prove that the triangles on either sides of these line segments are similar to each other. In all these three, we prove that the triangles on either sides of the line segment. They may be, the line segments may be altitudes or medians or angle bisector segments. We prove that the triangles on either sides are similar to each other, and also the main result, which is if the triangles are similar, the ratio of the corresponding sides is the same as the ratio of the corresponding medians, is the same as the ratio of the corresponding altitudes, is also the same as the ratio of the corresponding angle bisector segments. So here also the proof is by AA. So for angle bisector segments, AA. For altitudes, AA. For medians, SAS. Yeah, I'm not explaining this right now. Any questions, children?
No, ma'am.
Okay, Shakti says no. What about the others?
No, ma'am.
Please get your doubts clarified. Okay, Srinivasan says no. So the whole triangle is similar. So immediately write down this. When the triangles are similar, corresponding angles are equal and corresponding sides are proportional. This is the proof for the first one. This is the proof for the first one. We have to prove that ABE, this one, is similar to PQF, this one. So simple. In this triangle, angle A is equal to angle P of this triangle. That because from A. Then we know that this whole of angle P, B is equal to whole of angle Q. Because here B is equal to Q. This is ditto from A, the same reason I've put. Same reason from A. So when two things are equal, their halves are also equal. So
Ma'am.
am I audible, children?
No one you are.
Yes, ma'am.
Okay. Half of angle 1. What is, half of angle B. Half of angle B. What is half of angle B? It can be angle 1 or angle 2. And half of angle Q is angle 3 or angle 4, correct?
Yes, ma'am.
Yeah, so we write with relevance to the triangles which we have to prove are similar. So half of angle B can be written as angle 1 and half of Q is 3 because one is of this triangle ABE and 3 is of this triangle PQF. Yeah, so angle 1 is equal to 3, so the two triangles are similar. Write down, children, write down this, write the proof also, because this, as you write, you can understand mostly, then let's discuss. Finish writing? Still writing, children?
I'm writing.
Okay. All right, so here prove that the ratio of the perimeters of two similar triangles, not perimeters of any two triangles, ratio of the perimeters of two similar triangles is the same as the ratio of their corresponding sides. See, children, one thing is ratio on corresponding sides is equal to the ratio of the corresponding medians. Ratio of the corresponding sides is equal to the ratio of the corresponding altitudes. Ratio of corresponding sides equal to ratio of corresponding angle bisector segments. Ratio of corresponding sides is equal to the ratio of the perimeters. Now all are equal. That means the ratio of the corresponding sides is equal to the ratio of the corresponding medians, is equal to the ratio on the corresponding altitudes, is equal to the ratio on the corresponding angle bisector segments, is equal to the ratio of the perimeters. All these ratios are the same. The values would be different. Ratio is the same. Ratio. So if the ratio says 1:3, it can be 10 and 30, 5 and 15. Ratio is 1:3. They'll not have the same lengths. They'll have different lengths, but the ratio will be 1:3. So all these ratios. So in two similar triangles, the ratio of the corresponding medians and the ratio of the corresponding altitudes will be the same. All are equal. Just put all the results together. You will have the common thing, ratio on the corresponding sides everywhere. In all the results you have ratio of the, in all the results we have ratio of corresponding sides equal to something. Ratio of corresponding sides equal to medians, ratio of the medians, corresponding medians. Again, ratio of corresponding sides equal to some other ratio. Ratio of corresponding altitudes. So everywhere it is a ratio of the corresponding sides. That means all the ratios will be the same. That means the ratio of the, in two similar triangles, the ratio of the corresponding medians will be the same as the ratio of the corresponding perimeters. Think about that. So here, in two similar triangles, so ABC similar to PQR, we need to prove that the ratio of the perimeters is the same as the ratio of the corresponding sides. Ratio of the perimeters, not corresponding, if I mentioned that. Ratio of the perimeters is the same as the ratio of the corresponding sides. That's what we have to prove. So now let each of these ratios be equal to something like K. Let each of these two triangles are similar to each other. ABC is similar to PQR. We need to prove that perimeter of ABC by perimeter of PQR is equal to the ratio of the corresponding sides, AB by PQ or BC by QR or AC by PR. This is what we'll have to prove. Now let each of these ratios be equal to K. Let each of these ratios be equal to K. Now AB by PQ is equal to K. So AB will be equal to K times PQ. Cross multiply. K times K dot, meaning K into PQ. Similarly, BC by QR. See here. AB by PQ is equal to K. AB by PQ is equal to K. So AB is equal to K into PQ. Similarly, BC by QR is equal to K. So BC is equal to K into QR. AC by PR is equal to K. So AC is equal to K into PR. Now let's find this ratio. How do we express perimeter of ABC by perimeter of PQR? How do we express this? So perimeter of ABC is sum of the sides of that triangle AB plus BC plus AC. Perimeter of PQR will be sum of the sides of that triangle PQR, PQ plus QR plus PR. Am I audible, children?
Yes, ma'am.
All right. Now let's replace. We found something now. We know that AB is equal to K into PQ. So let's take away, instead of K, AB, let's write K times PQ. And what is BC? BC is equal to K into QR. BC is equal to K into QR. See here. And AC is equal to K into PR. So instead of AC, K into PR. So now K is common everywhere in the numerator. K out. So we get PQ plus QR plus PR. We have the same expression in the denominator, so they get cancelled. And we have the ratio of the perimeters is equal to K. But what is K? What is K? We get the ratio of the perimeters is equal to K. But K is nothing but the ratio of the corresponding sides. So this means from 1 and 2. I have marked this 1. This one is 2. From 1 and 2, it follows that perimeter of ABC by perimeter of PQR. It's equal to K. It's equal to K, meaning if it's equal to K, that means it's equal to all this. It's equal to AB by BC, AB by PQ, BC by QR, and AC by PR. This is the last step. We need to write 1 and 2. 2, no? 1 here. This is 2. This is 2. And then this one. This is the concluding step. This one is the concluding step. Yeah, write on these results. Question number 18, write it down. We'll see it later because you have to still learn the area theorem. I've shared the videos. I'll tell you about them at the end of the session. 18, we'll see later. Work the 19th one. Finish writing. Are we there, children? Done?
One,
Okay, okay, okay. Done, children?
Yes, ma'am.
Yeah. So I'll tell you something like a hint for proving these results. You need to know which triangles to consider. Which triangles to consider to get, supposing you'll have to prove this result alone, only this one. So when you look at this result like AC square is equal to, that means you must take up two triangles which have AC as a side in them. Both the triangles you take up must have AC as a side. And also see BC and DC. Where is BC? This is BC. This is DC. So tell me the triangle. See, the two triangles which you take up must have AC as a side. Tell me two triangles with side AC.
Triangle ABC and triangle ADC.
Yeah, ACB. So see here, triangle ACB, this one. ACB has AC in it. And again, triangle ACD also has AC in it. That's why we take up ACB and ACD and show that they are similar. We show that they are similar. Once you show that they are similar, their corresponding sides. Once you show that they are similar, their corresponding sides are proportional. You can write all the three ratios. What we don't write is that ratio which does not have AC in it. We have written this ratio because it has AC in it. We have written this ratio because it has CA or AC in it. So when you cross multiply, you get AC square is equal to BC into DC. So I think I told you how to select the triangles. To get a result like AC square is equal to something, you have to take up two triangles which have AC as a side. So ACB, ACD. Take up these two triangles, show that they are similar to each other. Once they are similar, their corresponding sides are proportional. Write down that. So you'll have to write three ratios. You should write the ratio only if it has AC in it. If it does not have AC, don't write that ratio. So we write AC by DC and CB. Children, you know ratio of corresponding sides, right? From the name of the triangles, you can write that from this name. So cross multiply and get that result AC square is equal to BC into DC. Audible, children? Is it clear?
Yes, ma'am.
Okay. Others?
Yes, ma'am.
Okay. So to get this result, so here AD square, AD square. So name two triangles which have AD as a side. AD.
Triangle ACD and triangle ABD.
Start with AD and then the third vertex, triangle AD.
ADC and ADB.
ADB.
Yeah, ADC, ADB. ADC and ADB are two triangles which have AD as a side in them. ADC, ADB. Both have AD in them. So take up those two triangles, prove that they are similar. In similar triangles, corresponding sides are proportional. Write that, cross multiply. So which ratio not to write? You should write two ratios. Two ratios will have AD in them. That one ratio which does not have AD, ignore it. So when you cross multiply, you will get AD square is equal to BD into CD. Isn't that simple, children?
Yes, ma'am.
Yes, now you should tell me. Yeah. And this one I told you earlier. I told you about this one. We're comparing the results. We have angle 1 is equal to angle 3. Angle 1 of this triangle is equal to angle 3 of this triangle. And then 90 degrees. So double A similarity. Nothing. It's like this. When you have AB square, you should take two triangles that have AB as a side. Both the triangles must have AB as a side. AC square is equal to, take two triangles which have AC as a side. AD square, AD as a side. Both the triangles must have AD as a side. See, that's how I named it also. See, ABD, ABC for AB square. Then I've written ACB and ACD for AC square. And I've written the proportion. No, I just forgot what I was telling you. I was talking to you about AB square. So we need to take up two triangles that have AB as a side. Here, ABD, ABC. Prove that they are similar. In similar triangles, corresponding sides are proportional. You need to get, here in this case, you need to get AB square. So you must write the ratios that have AB in them. If that ratio does not have AB, don't write it. So these two ratios have AB. These two ratios have AB. So you write that, cross multiply, you will get the result. Very simple, children. Is it fine?
Yes.
Yes, ma'am.
Yes, ma'am.
Okay. All right, children. Okay. Yes, do this. Work the 18th one. We'll wind up today's session with the 18th one. Please do 18. Very important question. Very simple. Very important. Only 18. Do only 18 now in today's class. So in figure 18, there are two triangles. One is AMN. The other is ABC. Show that they are similar. Write the proportion. Substitute the values or the variables given. And find MN in terms of PQR. We have only two triangles here, AMN, ABC. So in the two triangles, one pair of angles are equal, 76, 76. So in the small triangle, M is 76. In the big triangle, B is 76. And then both the triangles have a common angle at A. Children, sorry, I was away. I didn't excuse myself. Yeah, I was telling you that there are two triangles, AMN and ABC. Small triangle, this angle 76. Big triangle, this angle 76. So one pair of equal angles. And then this is the common angle. This is the angle common to both the triangles. This angle is present in the small triangle as well as in the big triangle. Common angle, similar. Once they're similar, their corresponding sides are proportional. So see here, I've written that. Corresponding sides are proportional. Write that. And then substitute. You have some letters, no? Given against the sides. Write all that. And see here, for AN by AC, we have nothing. Ignore this. You can go ahead only with two ratios. Am I audible?
Yes,
Yeah.
ma'am.
We can go ahead only with two ratios. AN by AC, leave this. Leave this AN by AC. Go ahead with these two. We have MN here. We have to express MN in terms of PQR. So cross multiply. And we have Mn is equal to PR by P plus Q. So we have expressed Mn in terms of PQR. P into R by P plus Q. Mn is equal to PR by P plus Q. We have expressed Mn in terms of PQR. So how was that? Two triangles. Prove that they are similar. In similar triangles, corresponding sides are proportional. So write out the proportion. Substitute, we have the letters P, Q, R. Substitute. Leave this ratio AN by AC. Take up these two ratios, cross multiply and write Mn in terms of PQR. All right, children. So that's it for today's session. How many of us are there now? Only 15. See? Not 15, 19. So 5 students already left the meeting. Very good. All right, children. So that's it for today's session. If you have any questions, please stay back, else you may leave the call. Thank you. Good night.
Thank you.
Thank you, ma'am. Thank you.
Thank you, children. Thank you. Thank you, children. Good night.